If you're stuck on a research topic, don't start with Google. Start with what you are really seeing in your clinic or lab. A good research question begins with who you are seeing. For example, adults after a first ever stroke. Then ask what you are doing differently and which one outcome matters the most. For example, task-oriented training. When you put who, what is different, and which outcome into one sentence, done.
Many projects fail because they try to measure everything.
Start by choosing one primary outcome, the main thing you care about in the study. Then choose just a few secondary outcomes that you can actually measure well, like weight, pain score, or satisfaction. One clear primary outcome and a small number of secondary outcomes make your analysis and your paper much easier.
Cross-sectional and cohorts sound complicated, but the basic idea is very simple.
A cross-sectional study is like a selfie. You check anemia in all pregnant women who attend your clinic this month. A cohort study is like a movie. You follow the same women over time and see who develops anemia. One snapshot versus a full timeline, selfie versus movie. That's the key difference between cross-sectional and cohort. Sample size is not 20 because my guide said so. When you pick a number randomly, you are also choosing random strength for your study.
For a study comparing two groups, you always need 4 ingredients: the expected difference between groups, how much the values correlate. Before you calculate, write down what you expect for each of these 4 ingredients. That's simple step 4. Then use a proper sample size calculator or ask a biostatistician to check your inputs. If your p-value is 0.03, it does not mean your idea is 97% correct.
It means that if there was really no difference, getting this big a difference just by random chance is about 3% likely.
P-value talks about how surprising the data are under no difference, not about your personal worth.
Use the p-value as one piece of evidence, not as a personality test. Your limitations section is not a place to hide problems. It is where you show that you are thinking honestly. In a radiology or imaging study, you can mention single center, small sample, one machine brand. For each limitation, add one short phrase about how it might affect generalization or how confidently others can use your findings. Being transparent about limitations makes your paper more trustworthy, not weaker, because readers know how to